EZ nomenclature, organic chemistry, CIP rule students. Okay, in geometrical isomer students, cis-2 trans 2 types are there, and here EZ nomenclature also is there. Okay, na? So when we have to use this cis-2 trans, so when we should follow EZ nomenclature, listen carefully. Cis-2 trans, the compounds which have the two identical groups are present in the given compound. See here, CH3, CH, two identical groups are there. Here, there. Two identical groups are there. Those compounds are classified into two types, cis-2 trans. Understanding? Cis-2 trans means we know the two identical groups are present same side of the doubly bonded carbon atoms, that is cis form. If the two identical groups present opposite sides of the doubly bonded carbon atoms, that is trans form. Okay, na? So two identical groups are there in the given compound. Those compounds are classified into cis-2 trans. Okay, the compounds which doesn't have two identical groups, the compounds which don't have two identical groups which are not having two identical groups. See here, this example, it is not having the two identical groups. See here, bromine, chlorine, hydrogen, iron, 4 different groups are there. So the compounds which are not having two identical group students, those compounds are classified into two categories, Z configuration, E configuration. Difference understood? So the compounds which have two identical groups, those compounds are classified into cis-2 trans. So the compounds which do not have two identical group students, those compounds are classified into two categories, Z and E configuration. Clear? Z configuration. So this EZ configuration is introduced by CIP students. Understanding? It is also calling as CIP rule. So here CIP means, C means Kanu, Ingold, Prelog. Understanding? Three members developed this one. Okay, na? EZ nomenclature, this one introduced and developed by the Kahn, Ingold and Prelog students. That's it. This rule is calling as CIP rule. Okay, now what is the trick box here? Trick box here. See here, higher atomic number groups. If the higher atomic number groups are present same side of the doubly bonded carbons, that is Z configuration. If the higher atomic number groups are present opposite sides of the doubly bonded carbon atoms, that is E configuration. Clear? That is E configuration. Now we see here one example. We'll discuss. See here, C double bond C. Here chlorine, hydrogen. Chlorine is having the higher atomic number, hydrogen is having lower atomic number. Here bromine, fluorine, bromine higher, fluorine lower. Understanding? Now higher atomic number groups are present same side of the doubly bonded carbon atom. So that's it is Z configuration. Clear? This is Z configuration. Now see this example, carbon. Here hydrogen, chlorine. Chlorine is having more atomic number, higher atomic number group, this is lower. In these two groups, bromine higher atomic number, this is lower. Now higher atomic number groups are present opposite sides of the doubly bonded carbon atoms, opposite side, that is E configuration. Higher atomic number groups present same side of the doubly bonded carbon atoms, that is Z configuration. Opposite sides there means E configuration. Clear students? Thank you students.